Hello, welcome. This is John Chibuguju going to take you through this video. If you have been outside there wondering why you are not understanding how a starter motor starter works, I'm telling you, my brother, my sister, things are simplified for you. In front of your camera, we have a starter motor starter power circuit. This is how we start. Here you are seeing a three-phase lines. We call it three-phase four-wire system. We have brown as L1, black as L2, and gray as L3. Members, the phase sequence changed from red, yellow, blue to brown, black, gray. Getting it? Yes, let's go. So, to wire a starter motor starter, you need the following. One is an isolator, as you can see it here. An isolator, this is a three-phase isolator. We need three power contactors. 1, 2, 3. Three power contactors. We need an overload relay. This is our overload relay. Basically, those are the things we need so that we can make up a starter motor starter. Let us go through them and you see how simple it is. So here we get our supply from bus bars. I hope everyone knows bus bars because bus bars are everywhere in electrical distribution, most especially in factories and everywhere. So on the bus bars they are labeled brown L1, black L2, and gray L3. So you connect brown L1 and black L2, gray L3. After connecting them, you take them to the isolator. You connect them to the isolator. From the isolator, you connect them to the contactor. From the contactor, you connect them to the overload relay. As you can see them running like this. Gray coming here through the isolator. Gray is here coming through the isolator to the contactor, through the overload relay to the motor terminal, and also black through the isolator, contactor, overload relay to the motor terminals, and also brown, the first phase, is also going through the isolator, contactor, overload relay to the motor. So this is the thing now. You connect it. First of all, if you understand the direct online, how a direct online motor works, you first connect a direct online. As you can see it here, this is a direct online here, this one. Isolator, contactor, overload relay, then to motor terminal. So you introduce another contactor. This contactor, you also give it supply with the same phase sequence. If you give it supply with the same phase sequence, for the input of this contactor will be connected at the same point with this one. We call it the main contactor. The main contactor is the contactor connected in series with the motor. Okay? In series with the motor. So the delta contactor is this one, which you connect in parallel with the main contactor. So you maintain the phases because, as you are seeing, brown is phase number 1. When you follow it, brown comes to number 1. You are seeing black is connected to number 2. When you follow it, black comes to number 2 right there. Yes. And gray number 3. When you follow gray like that's connected here, these dots show connections. So the gray is connected up to the last one. So it will be 1, 2, 3. 1, 2, 3. It's brown, black, gray. 1, 2, 3. Okay? So the output of the delta contactor, all the three phases are again connected to the star contactor. From down, as you can see, still we have maintained our phase sequence. You can see gray is the last one, black is the second one, and brown is the first one. As you can see the sequence. I know you are not blind, you can see. I know people watching this video are all having good sights, you can see. So for the star contactor, we short all the three phases together. Shorting in electrical means connecting all the three phases together. In other words, to get the neutral point. Shorting all the three phases together, it's like getting the neutral point. We shall see how to get the neutral point in the video coming soon. So we connect, when we go back here to the overload relay, we connect our U1, V1 and W1. These are the motor terminal. At the motor terminal block, we have U1, V1 and W1. Okay, anyone can call it, some people call it RRST, but for me I've loved to use UVW. From the left hand side, you can see from the left hand side, this is the left hand side, UVW. You may ask yourself, what are these things inside here? This one is representing a motor. This circular thing here, this circular diagram here is representing a motor. Please, this is a motor. So inside the motor we have windings. All those windings, they may be 100, they may be 200, they may be 300, 400, but they are all connected to get 3 windings. If we get 3 windings out of thousands or hundreds of what is inside there, that's done during rewinding. So all the coils will be connected so that we get 3 phases. Remember, the coils have the start and the end. So here we have the start of U1 here and the end of U2. This is the same coil. When you test continuity, this will give you continuity with this when you are using a multimeter. Hope you know how to use a multimeter. Someone out there who doesn't know how to use a multimeter, I'll come back with a video which shows you how to measure using a multimeter. So here you connect our brown to U1. You connect our black to V1. You connect our gray to W1. You maintain. After maintaining like that, you connect U2. This one here is U2. You connect U2 to, you can follow it, U2 is coming like this to, this is gray. U2 is coming to gray. So it means that in star delta motor starter, you will connect same phases with different, same coils with different phases. The incoming of the coil, you give it here. Here we have seen the incoming of the coil, we've given it brown, and the outgoing we have given it gray. The outgoing we have given it gray here. So for V1 is the incoming of this coil. We have given it black. As you can see here, black, this dot shows that we have terminated here our supply to the motor. So you can see black is coming here, and the outgoing here, this one V2, you connect V2 to brown. You connect V2 to brown. Okay, after connecting V2 to brown, you come here and check W1, which is the third coil. W1, at first we connected it with gray, as you can see, and at the end of the coil we brought in something called the black, as you can see. So here it will be brown, black, gray. Here it will be gray. This one is coming to gray, as we have seen. This one here is coming to brown. Here it will be gray, brown, black. Okay, W1 is coming to W1, W2 is coming to black, as you can follow. So members, that's how we wire a starter motor starter. So you leave alone the shorting here. The shorting, that's enough. For the star contactor, you just short on top of the contactor, and then you maintain the phase sequence as you are looping it to the delta contactor. Members, that's how a star delta motor starter is connected. So let me now explain to you how a star delta motor starter works. This is the working principle of a star delta motor starter. Here, a star delta motor starter, once we press the start, once we command our motor to start, the main contactor and the star contactor will get energized at the same time. Members, I mean at the same time. So this one will supply the motor. When this one has shorted, the motor, as you can see, terminals U2, V2 and W2, they are going all to be shorted from top here. Top of the star contactor is the one which does the shorting. In other words, if it was a small direct line motor, we could short here from the terminal box. It will be easy for us to short here. But since we also need the delta connection sense, so we do the shorting from outside here at the contactor. After some around 9 to 10 seconds, this star contactor will open. Once the star contactor opens, immediately, a star delta contactor will get energized. Once it gets energized, it will supply our coils here, so that the motor starts running in delta connection. So members, that is it, how we work on the star delta contactor. Thank you. Members, the circuit diagram right on your screen is the control circuit for a star delta motor starter. We've seen the power circuit, yes, but how does the power circuit achieves what we've been talking about? This is how the power circuit achieves, how it works. So members, I want us to go through the circuit diagram as you see it on your screen, and you understand it better. I know you have been seeing different control circuits for star delta motor starter, but this is the easiest, my friends. I'm telling you, this is the easiest, because I'm the one who brought it up. I understood how it works. I came up with something simple, because the other ones are very difficult for me to understand. That's why I came up with such a simple circuit diagram. I know it's going also to be simple for you to understand how it works. Let's go. So you can see it very simple, that we have 1, 2, 3, 4 coils. But you may ask yourself, I saw 3 contactors, why am I seeing 4 coils on the control circuit diagram? The answer is simple. The switching from star to delta, the switching from star to delta is done with a timer, friends. A timer is the one which makes this circuit to be called an automatic star delta motor starter. People, a timer is very useful when it comes to star delta motor starter. So as we can see here, this is timer coil. This is our timer coil. So this is what we need in order to come up with a control circuit of a star delta motor starter. 1, we need an MCB, as you see there. Second, we need the push buttons, the start and stop push buttons. And the third is a timer. The rest are on the power circuit, like the overload relay, the coils, and the contacts. They are there on the power circuit. The new things which we introduced in the control circuit is we need an MCB, the control MCB for the control circuit, and we also need the start and stop buttons and the timer alone. The stop button is supposed to be an NC as you see it here. The start button is an NO as you see it here. So members, let us go through this and you see how simple it is. We have assumed that we are picking our supply from the brown, the L1. Brown is the L1. Members, I tell you this, we are no longer using red, yellow, blue. Nowadays we are using brown, black, gray. Most of you people may say gray is used for, I think gray, you have never seen gray anywhere. Black is used for either neutral or some other things, but here black is carrying voltage. Here black is carrying voltage. So it is we have assumed that we are using the brown phase. So we connect here our brown. This is the same bus bar. We connect here our brown. We take the brown through the MCB. From the MCB to NC of the overload relay. Members, from the NC of the overload relay, we connect it to the normal stop, to the stop push button, which is the normally closed. Stop push button is normally closed. From there, we connect it to our start push button. But members, something new is here. How it is simple. The main coil, I'm telling you a secret. The main coil, you connect its control as for the direct online motor starter. If you know how to connect the control for the direct online motor starter, you should use the same criteria to connect the main coil control on the starter router, like the other one for direct online. You can see it here because from the stop push button to the start, from the start push button to the coil, and also to the main coil, and also the self-holding is achieved as you can see here, that the start button is connected in parallel with the auxiliary normally open contact of the main contactor. Okay, this is the way we do here our control circuit for direct online. So the only what we are going to add here, from the start push button, members, from the start push button, outgoing, from the start push button outgoing, you connect there so that you can also take it to supply NO, normally open of the main contactor. As you know, we can put as many auxiliary contacts as we can on the contactor. So you pass it through another NO if you want, or if you don't want, you can still use the same. So through this NO, this is NO of the main. NO means normally open, not no main. Most of you people think that it is no main. No, it is normally open of the main contactor. It's the one supplying the timer coil. Members, are you seeing? It's the one supplying the timer coil. So from there, you take the same supply where you got the supply from. So it's a loop. It's a loop, isn't it? Yeah, it's a loop. So you from the incoming of this, you connect it to the NC of the timer. Okay, very simple. You connect it to the NC contact on the timer. So the outgoing from the NC contact of the timer, members, we take it to the star coil so that it can control the star contactor. The star contactor is controlled by the normally closed contact of the timer. Okay, then from there you get the same supply, you pass it through the normally open of the timer, normally open contact on the timer. Okay, so the normally open contact of the timer goes to the delta coil. Okay, we can set, we have said 9 to 10 seconds. So this is an example. If we press here the start push button, we can see power will move straight to the contactor, and if we release the the start button, power will take the alternative way, which is giving us self-holding so that it can continue supplying the main coil. We can see on the main coil still the normally open of the main coil. Once this gets energized, this will close. We are very sure this will close. After this one closing, automatically, don't ask me why, how, automatically the timer coil will get energized. So when the timer coil gets energized, it starts timing. The time we have set it to last for, it's the one that it will take. If you have set 10 seconds, the timer will start counting down 10 seconds. But before 10 seconds elapse, the start coil will also be energized. For the 10 seconds of the timer, I'm assuming we have given the timer to last for 10 seconds. So the 10 seconds of the timer will be energizing. It's the time that the start coil will be energized, because the start coil is energized through the normally closed contact of the timer. Once the 10 seconds are done or they have elapsed, this will open, and once this opens, this will close simultaneously. The word simultaneously means doing two things at the same time. So once the NC opens, the NO will close. So when the NO closes, our delta contactor will start moving. So when our delta contactor starts moving, that's when we shall be getting the start delta motor starter going to work. As you can see here, the return, we have collected the return for main coil, timer coil, start coil and delta coil, and connected back to the neutral. Members, this circuit is all about the coils are of between 230 to 240 volts. But if you get the coils of 415 volts, you bring this to any phase that you want, to either gray or black. But I don't know, I've never seen a timer of 415 volt coil. If there is any timer of 415 volt coil, you do the same and you connect them here or anywhere you want on a different phase. But if the timer is of a different phase, you make sure that the return for the timer, it's the one which will only come to the neutral. The rest, collect them together, bring them to the next phase as of your wish. So members, that's how start delta motor starter works. Thanks for watching. Don't forget to subscribe for new videos. Bye bye.